back into my proof. So I'm going to use that rational root theorem over there. The rational root theorem says this. If this polynomial does factor nicely over the integers, then I think my rational 0 p over q is going to have the quality that p divides evenly over the constant term, q divides evenly over the coefficient. So I think my only two choices are plus or minus 1. Not many choices. You think it's going to be 1? Probably not. So when I plug 1 in for x, I don't get 0. Let's try negative 1. And if I try negative 1, push it through the process using synthetic division as a shortcut. You guys, help me. Drop it like a rock? Yeah. And then, I said, you help me. Then multiply by the number of the box, throw the product in the next column above the horizontal bar. But unlike polynomial long division, now we're going to add column by column. Here's my sum. Oh, it's below the bar, so multiply by the number of the box, add, multiply, add. I'm happy. The fact that my remainder is 0 simply means x minus this number is a linear factor as a polynomial expression. And I think that allows me to rewrite as such. It allows me to rewrite this integral as the integral of my 1 plus the same darn stuff upstairs all over the product of x minus negative 1 times the corresponding trinomial that remains standing. Now to factor the trinomial further, I have to confess, I really can try to evoke the rational root theorem. It's just this trinomial. Why bother? If they're going to be rational zeros to a trinomial, it simply means the trinomial is factorable. Look at it. Does it factor nicely?
No.
No, it doesn't. I'm kind of stuck. And if I'm kind of stuck, that means maybe I should dive in and just give up. Treat the second trinomial factor as irreducible. And see if I can't commit to partial fraction decomposition. So here's my second piece of scratch paper. Let's you and I consider that one proper rational expression, which is that one fraction to the right of the addition symbol. This one. Now, committing to partial fraction decomposition, can't I think of this as something over x plus 1 plus something over x squared plus x plus 1? However, if you were to multiply everything out downstairs, well, actually, it already was as such. This is third degree. This is second degree upstairs. This is proper, which means that I can break this up into sum of two fractions, each of which will be proper, meaning the numerator of the first fraction can be at most of degree 1 less than the denominator. That's degree 0. That's just a constant. However, the second fraction has a numerator whose degree could be as big as degree 1 less than my denominator. That'd be 1. That would be involving x. I think it'd be a linear expression. But I think I need to write with my pen the most general linear expression. That would look like this. It's my mathematical responsibility to find values for a, b, and c, so I'll dive in and clear fractions. I think that gives me that negative 2x squared minus 2x plus 1 is nothing more than an a times x squared plus x plus 1 plus my bx plus c times my x plus 1. Now let me close my pen and just talk. I think I can blow everything up. On the right-hand side, equate coefficients. Generate 3 equations and 3 unknowns. Here it might be a little bit more viable to use Gauss-Jordan elimination on an augmented matrix, or rewrite the system of 3 equations as a single equation and use inverse matrices to solve the system, or use determinants and employ Cramer's rule to solve the system. I just maintain here too, you guys, I think it's a lot of work. To avoid all that garbage, let's just you and I play with pretty numbers. Would you guys not agree that if I allowed x to be equal to 0 of that linear factor, doesn't this imply this whole second grouping drops out? And don't do any work. Clearly, I think I'm left with one equation and one unknown, namely a. Let's see what I got. Plugging negative 1 in for x. Ooh, that's nice. That's 0. That's just 1. And on the right-hand side, I got a times, I don't know. Is that an a times 1? Oh, jeepers, is that nice? You guys, I made this example up out of thin air. I really didn't expect the answer to be that nice. Next. If I allow x to be the zero of the next linear factor, oh shoot, there isn't one. A plus c. Where'd you get a plus c? You know, you're right. I can plug 0 for x. I'll generate an equation to a node. That is perfectly viable. I wasn't even thinking of that. I was actually just trying to be lazy. I was thinking of maybe just equating coefficients of x squared. So equating coefficients of x squared, what do I get on the left-hand side as a coefficient of x squared? I think that's going to be equal to the coefficient of x squared on the right-hand side, but that's just a plus b. But I know what a is. A is equal to positive 1. That necessarily implies that b is equal to, that's arithmetic, negative 3? I get that lonely feeling again.
Can you explain that, the second step again?
All I was doing is this. David, I don't want to go through all the work of blowing everything up, equating coefficients, setting up multiple equations, multiple nodes. I was just cheating and setting up one equation in my head. I said, if I blew everything up, the right-hand side, the coefficient of x squared on both sides has to be the same. It's just the coefficient on the left-hand side is negative 2. That's where that came from. But if you did go through the work, but don't do it. If expanding everything on the right-hand side, I think here's a coefficient of x squared a. Well, there it is. Plus, this coefficient, if I FOILed out, first times the first, would be another coefficient of x squared. I was just equating coefficient of x squared without doing a lot of writing. Am I doing okay? And lastly, let's equate constants. I think the constant on the left-hand side is this. I think the constant term on the right-hand side is a. Is that a plus c? But that necessarily implies that c is equal to 0, because a is equal to 1. Ah, shoot. Look what I've just accomplished. I've accomplished decomposing this proper rational expression into sum of two other proper rational expressions. Let me write what I have. This gives me the integral of 1 plus something over x plus 1 plus something over x squared plus x plus 1, and I'm anti-differential with respect to x. I just forgot what I found. I'll go back. A is 1. B is negative 3. And C is equal to 0. What's next? What is next? I think I can break up the three integrals. Yes or no? Piece of cake?
Yes.
Yeah, absolutely.
Yes.
Don't even think. Okay, let's
U sub.
You know, I think a U sub would be great if what you see upstairs is the derivative downstairs, is it?
Not entirely, but you can
Ooh,
pull an
keyword,
X out. Yeah.
What do you want to do?
Just make the U equal to downstairs.
Okay, but that means I have to add my funky looking form of 0.
Yeah.
I said I have to add my funky form of 0.
Oh. I might not be thinking that way.
What is that?
Yeah, anybody? Minus 3 halves? Am I alone? You said yes. Oh, okay, do this. Don't listen to me. I got an idea. If I allow you to be the denominator, what would du be? 2x.
2x plus 1.
Plus 1. Coefficient of x is twice that of the constant. Well, here's a coefficient of x. It's going to have to be twice the constant, which means a constant will have to be half the coefficient of x. That's just...
Say that again?
Okay, I'll say that again. If u is equal to this entire denominator,
Yes.
wouldn't du be 2x plus 1?
Yes.
Well, 2x plus 1 dx. No, I'll do that. I said if u is equal to x squared plus x plus 1, did I write that correctly?
Yes.
Then I think my du has to be 2x plus 1 dx. Don't you guys appreciate how the coefficient of x is twice that constant?
Yes.
So if I commit to such a u sub, it's got to be the case upstairs that that coefficient of x has to be twice that constant. Huh. I'll just fix the issue. Now my coefficient of x is twice that constant in red. It's not legal. I gotta compensate by adding a 3/2 back in. I'm just, yet again, adding my fucking looking form of 0. Now the beauty behind this is now I have the integral of 1 with respect to x, piece of cake you said, plus the integral of 1 over x plus 1 with respect to x, piece of cake again you said, plus the integral of my negative 3x minus 3/2 over x squared plus x plus 1, which I hope you agree at this point, with my u sub, is a piece of cake. Plus my 3/2 over that trinomial, for which I can evaluate by last night homework, by the work you did outside of class yesterday, by a trig sub. After I complete the square on x. Thank you. So you guys ready?
Let's do it.
Okay, let's do it. I think with that first integral, I'll just state the answer. With the second one, falling asleep, I'll state the answer. With the third one, I'll slow down. You know, technically speaking, committing to the substitution, I guess I've got downstairs just simply a u. It's just that when it comes to my dx, oh sorry, right down here, notice, to generate a coefficient of 3, or a negative 3 right here, what would I have to multiply both sides to generate on the right-hand side this negative 3x minus 3/2? What would I multiply the left-hand side by to get this? Stop thinking. Look at the 1. What do you multiply that by to get this? You said negative 3 over 2. Do you guys agree? And so I think that third integral becomes nothing more than 1 over du. Oh, I forgot that coefficient. I'll pull it out.
Sorry, you said multiply. Would you divide to do whatever on the other side?
But I don't need to, because I'll see it differently, Dave. Watch. Do you agree in green? Exactly what you see here is exactly what you see here.
Yes.
Then I merely get to replace it with my negative 1, negative 3 has du. You're fighting it.
I don't see it. It's not jumping out at me.
Then don't go there yet. I think there's something else missing.
Okay.
How about this instead? You agreed with this commitment to my substitution.
Yes.
It's just that directly I don't see a 2x plus 1. I see this instead.
Yes.
So I simply ask myself, since this is what I have in the Lagrange position, let me just write it down.
Okay.
But this is not equal to this.
No.
I gotta multiply this by negative 3/2 to get this one.
Yes.
Multiply this by the same negative 3/2 to get this.
Yes.
So let's be consistent. Let's multiply the left-hand side by negative 3/2
Oh,
as
so
well.
just funky formula 1.
It's just a funky form of
Got
one.
it. Okay.
Oh, by the way, with the last integral at the very bottom, allow me to pull the 3/2 out. I think what's left over is the integral of 1 over, I don't know, is that an x plus 1/2 squared plus 3/4? You guys get silent so well. It's really good at it. Let's practice. And I think that gives me my x plus natural log of the absolute value of x plus 1 minus 3/2. Can we just state the answer?
Natural log of, where is it? X squared plus x plus 1.
Absolute value.
I can't hear you.
Absolute value.
I can't hear you.
Just regular. Brackets, parentheses.
Because it's always positive.
Yes.
I think the absolute values would be superfluous.
Can we still put them in there though?
Ooh, it wouldn't look very pretty, would it? You want it to be as clean and as natural as possible.
I think straight lines look cleaner than curved lines.
Touche, that was good. And what about over here? What do we need to do?
What do we do?
What do we do?
Let your x equal 8
It's too much
tangent.
work. It's too much work. Just state the answer.
Would you-
Plus root 3 inverse tan.
what?
My loneliness feelings coming in again.
X plus 1/2.
2x plus 1 over root 3. We're going to check the wall chart. It's not 31, isn't it? Guys, is that okay? I mean, can't you just clearly say, oh, this looks like a 1 over z squared plus a squared? That's just inverse tan. So I multiply on the outside by 1 over a. I did, cleaned up. And I got on the inside the inverse tangent of this over my a. I just multiplied top and bottom by 2 to get rid of fractions. Does that look as clean as I can get it?
Yes.
Yeah, I think the answer is, yeah, probably as clean as I can get it. I admit, somebody might say, well, we can combine these two logs. I just don't know if it looks as pretty. I don't know, I really don't. I think you have a choice. Natural log of the ratio of the absolute value of the sum to this trinomial, raised to the 3/2 power, plus root 3 times the inverse tangent of my 2x plus 1 over root 3. I'm serious, I don't know which one looks nicer. You choose. Yes?
Can you walk us through the inverse tangent part of the integration?
Yes. Can you do this? So it does look like a z squared plus a squared. You guys help me. A is root 3 over
2.
2. And so I think I get that lingering coefficient times, now listen to why I say this, my 1 over a. Inverse tangent of my z over my a. My 2's cancel. My root 3's cancel. Life isn't very pretty. Got fractions embedded in a fraction, so let's clean things up a little bit. Pulling out my Math D broom, I will multiply top and bottom by 2. At least I get some cancellation downstairs. Oh, by the way, as well as upstairs, but I've got to distribute. Is that what I got? Oh, thank goodness.
So is there a way of doing that with U subs? To
Absolutely.
make it
I could
easier?
have made this a lot
Yeah.
longer and used maybe 4 more boards. By
Okay.
diving and looking at all the details by saying, oh, let's let u be equal to x plus 1/2. Did I ever use u's? I did. So can I take that back? I'll let z be equal to that. So dz is equal to this. That cleans this up.
yeah. Okay.
I just avoid it. Okay, because you're quiet, I have to ask a question. I do when you guys get this quiet. Am I putting you to sleep? Because it's so easy? Or am I annoying you to death that you think this is possible?
Well, this was all one
Ooh,
example.
ooh, all right, I guess I misread you. I thought you guys thought this is too easy. Excuse me, before I look at any more, is there anything here I can clarify? Before I erase it and move on? And go through some more examples so you can understand what I'm actually doing. Yes, sir.
Our examples and the homework and on the tests and quizzes aren't going to be this long, right? Hopefully.
Huh?
Hopefully aren't gonna be this long.
We got such leisurely 2 hours for our exams. That's so much time. You have to admit, a lot of this is just arithmetic, isn't it?
Yeah, if we have one problem for the exam,
Well, I hate to call them problems. They're exercises.
exercises. I mean, because we did use pretty much everything from chapter 7 so far. So if you give us this one
And the 3
problem for
prerequisite
the
courses,
example,
yeah. I think this is an easily fair game for exams. Easily. You just gotta mind your P's and Q's.
I should take half the exam.
Nah, not that much.
Not for you.
I'm sorry, I got it in my head.
I thought the, when you let x, when you have that coefficient, you let x equals a times tangent, not a 1 over a tangent.
No, it's 1 over a. If you're gonna evaluate this integral right here, what we did in class, we derived it as being this: 1 over a inverse tangent of x over a plus c. I had the over a both on the inside and the outside. When it came to the inverse sign, I have to confess, the a didn't pop out in front. There's complete cancellation. I was just left with the inverse sign of x over a plus c.
What am I not thinking then,
But you can show me if I'm wrong.
no,
all
I'm
ears.
sure you're right, it's just, cause this part right here, if you look at this is what I'm referring to. X equals a tangent,
What about it?
it's not 1 over a.
I know, but that's merely the substitution. That's saying to commit to substitution, use it. I'm just saying, we already valued the integral in the past, and we came up with 1 over a.
Okay, no, I do recall.
You're at a different stage. You're at the
Okay.
beginning, I skipped all that.
Oh, okay.
Anybody, yes, sir?
So is that x plus 1/2 the x part of the equation? And then
It
the
really
equals
is,
the a
it's
squared
really the
part
X
of the
part of
equation?
what you see down here. That's why when I said that loud, I called it a Z,
Okay.
just to distinguish them. Anybody else? Yes, sir.
On the far left,
Yes.
I get how you just added terms to make it easier, but when you use the polynomial long division, what does the 1 at the top represent again?
Quotient.
Is that like a coefficient of a binomial or something?
Quite the
Like a
contrary.
number?
I'm not trying to insult you with it, but let me bring it back down to literally the first grade, to impress upon you it's all the same business. Watch. Back in the first grade, they trained us to pull out a nifty little division bar, put the numerator in the dividends position, the denominator in the divisor position, and play the game. 2 goes in 11, how many times? And paying the consequence, 5 times 2 is 10. Look at the difference, we got a 1. But since this is smaller than the divisor, I'm done with the process. And therefore, sir, just like I had on the board with the long division process, that quotient, which I think for you and I was a 1, that really is saying that 11 halves is equal to that 1, or in this case, my 5, increased by the ratio of my remainder to my divisor. Because I think 11 halves is equal to 5 plus 1 half. They messed with our minds in the first grade. They said, oh, suppress the addition symbol, but we would never do that now that we're so mathematically mature. Because for you and I, juxtapositioning means multiplication. But sir, I really think when on middle board, when I said I did it and I crossed it out and said too much work, remember above the division bar, I think there better have been a 1 up there. And that was the term here, which is not a coefficient because the addition operation. It was my quotient to which I added the ratio of my remainder to my divisor. Am I answering your question? Anybody else? All right, let's do it again. Gosh, you guys, we came so close to, if you solved it with 0 here, we came so close to. It looks like the equation, quadratic equation you get to generate one of the top 5 most important numbers in mathematics. Nobody in this room is going to answer my question? One of the solutions to this equation is golden ratio? Never mind. Maybe I can get the 3 examples today. What do you think? Yes or no? Is it the case in the radicand's, in the integrand's position, I've got a proper rational expression? I said yes or no.
No.
Well, I think the answer is yes, it is proper. Degree upstairs is strictly less than downstairs. Here's another question, yes or no? Can I snap my fingers just like that and demand you guys give me the answer? Can you evaluate the integral just like that? No, you can't. I think it's too difficult. But I do think if I split this up into other fractions, maybe I can integrate those individual fractions more easily than this relatively nasty fraction. So here too, you guys, I think this is a good candidate, no tricks, for a partial fraction decomposition. So you guys allow me to pull out my piece of scratch paper. I've got this one fraction, x over this linear factor duplicated twice, times its quadratic factor. I will set this equal to the sums of fractions, like an a over x plus 1, plus b, x plus c, over x squared plus 1. Plus 1.
That's a over x plus 1 because there's 2 and then it's 2a over x. Isn't that you doing this?
Why?
I just remember that's what you do on it, right?
right, but I wanted to make this mistake to justify why you're right. So you guys pretend this is the way I'm gonna decompose it, because I don't want you to think of it as a trick. If I decompose this way, let me go backwards. Let me combine it back together to get a single fraction. Wouldn't it be this? Which is this upstairs. But can you guys appreciate this denominator? Isn't the one I started with. I'm missing a linear factor of x plus 1. And so I think I gotta add another term in here. How about b over x plus 1 twice? So I can bring it up to this denominator. I'll change this to a c and d. I want a yes or no answer. Does that fix it?
Yes.
Yeah, I think it does.
But doesn't it
Shouldn't
give
it
you
be
x
just b
cubed?
over x plus one?
B over
Shouldn't it be squared? The second.
Because I needed a squaring down there in the original fraction. David. No, honest, be honest.
Well, why, if you multiply x plus 1 times x plus 1 squared, that'll give you a cube? No?
Oh, so
Yeah.
you're saying I'm overdoing it. I should just do that.
Sure.
Gotcha. Okay, let's run with it. Let's see if he's right. If I had to rewrite these two as a single fraction, yes or no? Would this be the denominator?
Yes.
Yeah, which is what I really wanted. Let's check out what the numerator is. I think my numerator is going to be b times x squared plus 1 plus cx plus d times x plus 1 twice. But I think that would give me a bx squared plus b plus, well, a cx squared, excuse me, I misspoke, cx cubed, plus cx squared plus cx, plus my bx squared plus dx plus d. But that would give me an x squared term, whose coefficient is, oh, I misspoke, everybody, sorry, I missed the x cubed term, I'll put that first. Whose coefficient is this? And I get an x squared term, whose coefficient is this. I get an x term, whose coefficient is this. And finally, constant term, whose coefficient, or whose constant is this. But I don't know, you guys, do I have complete freedom in here with these coefficients? I mean, does that mean my coefficient for x cubed, squared, x, even x to 0 power, are they going to be completely free, or do they depend on each other?
Depend on each other.
And so the problem is that, if they depend on each other, then I don't have complete freedom. Besides, watch, let me cheat. Yes or no, is that quadratic? It is. And if it's quadratic, I think I should get something like this. Can I separate those real quick? Separate them. I got a bx over this plus e over this. But I maintain that I can rewrite the e as this. Which means I get an f over here. Oh, by the way, now pulling out the b, since I put the f over there, I get an x plus 1, they cancel. And that comes down to just this. To the first power. It's just a different way of looking at it. Did you catch that, or did I erase too much?
No, you can go back one.
Ooh, you didn't like it. Let me say that again. Here's what I initially had. I said, is this sufficient? I maintain the answer is no, because technically speaking, that denominator right there is quadratic. I think since it's quadratic, I have to have a numerator that's as big as something that's linear. It could be as big as a linear expression, like this. Now you guys watch me play for a minute. There's nothing wrong with the board. This works. If you don't like what I said before, ignore it. This works. I just think it's too much work for this reason. When I see a big bx plus f upstairs and x plus 1 downstairs twice, I think that's the same thing as this. I'll break f up into b plus g. I'll take a mathematical x right there. And I think I get this. I'll factor out a b from the numerator of the first fraction. I'll perform a tad bit of cancellation. Give me a b over x plus 1 only once, plus a g over x plus 1 twice. I maintain, having my numerator for the quadratic expression downstairs, the numerator has to be as big as linear, or I can cheat. I can just simply say, since my denominator that's quadratic is a duplication of a linear factor, to make my life easy, I'll think of it as a constant over the linear factor plus just a single constant, not a linear expression, over that linear factor downstairs duplicated twice. Just an alternative way of doing it to make my arithmetic easier. So, if you don't like what I said, don't listen to me. Keep it quadratic, deal with it like this. Personally, I'm this lazy. I say to myself, well, there's a linear factor downstairs duplicated twice. I can split that up into a constant like an a over it once, plus another constant called a b over it twice. And I think those would be easier to anti-differentiate if I could find values for a and c. I do think that would be equivalent to just keeping downstairs as thought as quadratic and write my numerator as a linear expression. Allow me. I'll get rid of fractions. Maybe you can see how nice this really is. That gives you an x. B equal to a times x plus 1 times x squared plus 1 plus b times x squared plus 1 plus cx plus b times x plus 1 twice. Here too, I'm too tired. Look at this. If I expanded everything out and equated coefficients, I'm too tired to write those 1, 2, 3, 4 equations and 4 unknowns, for which I really would use one of those techniques of Gauss-Jordan elimination. Inverse matrices, or Cramer's rule. But maybe here too I could just cheat. And maybe finagle some nice choices of value for x. Like for example, if x is a linear factor, well, I misspoke. If x is a 0 of that one linear factor, namely negative 1, the last grouping drops out. The first one drops out. I think it simply tells me that 2 times b is equal to negative 1. Do you guys agree? You too tired to respond. And, oh no, I ran out of linear factors. Ah, shoot, I guess I gotta rely on just equating some coefficients at this point. How about of x cubed? Let's equate coefficients of x cubed. What is the coefficient of x cubed on the left?
A.
I can't hear you. 0. On the left. Big.
Oh.
And on the right-hand side, you know, you're right, I see the a. I guess the coefficient of x squared is going to be an a plus nothing here. Oh, but wait a minute. That's plus a c over here. Okay, you guys, that's pretty useful. Maybe I can't, however, use it to find the value for a and c quite yet, but let's keep running with this. What about doing something else that would be kind of easy? How about equating constants? And I think equating constants on the left I get 0. But on the right I get a plus b plus, I can't hear you. D. Shoot, I'm still not there. How about equating coefficients of, you tell me, what's left?
X.
You want an x. If I equate coefficients of x, I think that gives me 1 on the left-hand side. On the right-hand side, that's going to give me
A.
yeah, don't do a lot of work. Don't FOIL everything out. If you were to FOIL everything out, the only way you're going to get an x term is this times this. Oh, but the coefficient of out front is. Now in the second grouping, how am I going to generate a coefficient of x? No, I'm not. There is no coefficient of x, or even an x term in the second grouping. Over here, let's be a little careful. Isn't this this? So I think I could generate a coefficient of x over here by taking this constant term times this term involving the variable x. That would give me a coefficient of c. And I think, oh, over here too. Maybe here's a coefficient of x, namely 2 times d. But you guys, I insist, I'm still too tired, bless you, to do a lot of work. Can we look at this equation? And this one? And if you subtract the first equation from this one down here, doesn't that just simply tell you that d is equal to 1/2?
How do you just subtract it?
Because it's perfectly legal. I can take any equation like this one, subtract it from this one, the a's cancel, the c's cancel.
They're not equal, so they're the same.
That's okay, because I'm left over subtracting a and c with a 2a being equal to a positive 1. David, do this. Back in the 9th grade. How'd you solve that equation?
Subtract that 3.
But if you subtract 3, doesn't that mean the same thing as taking this equation and adding them together?
Yes.
Or maybe taking this equation, subtracting the second from the first? That's exactly what I did. It's just 9th grade algebra disguised.
Stuck to it.
You slept through it. You missed that day. Oh, you guys, I'm still not there. Darn it, I found my b value, I found my d value. Let's find something else.
I have a question.
Yes, sir.
Why isn't, for the line, with the constants, why isn't there a C? C?
Because I think if you were to carefully blow everything up, c is always being multiplied by x, it would never generate a constant term. And I was being lazy, sir. I didn't multiply everything out. I was just simply saying, the only way through this multiplication process I can generate a coefficient for x, or maybe generate an x term, is this times this in red, and in green. This times this, that would generate an x term, and that's where I got everything down here. But you have to confess, in blowing everything up, the only constant term you generate is a d. That's where that one came from. And you guys, I'm still too tired. I don't want to do a lot of work. Let's continue to cheat. With my green pen, can I take this equation? I mean, I know that d is 1/2. I know that b is negative 1/2. Doesn't it say that a is equal to 0? And what am I missing? Oh, my c value. But now in red, look at that equation. If a is equal to 0, substitute it for a. What do you get for c?
0.
Ooh, how nice. That being the case, I have succeeded in decomposing the original integrand into other fractions being added together. I committed to partial fraction decomposition. Let's put it all together. Let's see if it does make our life easier. Now I have sitting in front of me the integral of, I don't have any idea, I've got to look. My a is 0. My b is negative 1/2. I suppose we found our c to be, oh, look at that, it's just 0. And finally my d was found to be positive 1/2. You guys, seriously, no tricks. You have to confess. My life is really easy, isn't it? Let's just state our answer.
Negative 1/2.
I can hear you.
Negative 1/2.
Say it one more time.
1/2.
Positive 1/2. Boy, you guys really don't want to play anymore. 1 over x plus 1, I heard that. Plus 1/2
That's long.
inverse tangent of x plus c. Are you guys there?
Yeah.